Hello, this is 3.3 Notes. This is Mrs. Nicholas, and today we're going to see how to graph exponential functions. So, basic parent function is y equals a b to the power of x, and variable is my exponent, therefore it's exponential function. If b is greater than 1, then function is an exponential growth function, and it is increasing. If b is less than 1, the function is exponential decay, and it is decreasing. Now let's fill in the definition of asymptote, which is just a line which the graph gets close to but never crosses. Take a look how to graph exponential function. Let's see in example 1 how to graph function f of x equals 2 to the power of x. So first let's do table of values, t-table, and I can pick for x values negative 2, negative 1, 0, 1, 2, and maybe 3. So here, as a side note, when I plug in 2 to the negative second power, we use the negative exponent rule, and here comes out to be 2 to the negative 2 to the second power. So it's 1/4. Next point is 2 to negative first power. So once again I need to use negative exponent rule. It's 2 to the first power. When I switch it, so it's 1/2. Now next one is 2 to the 0 power is always 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. Okay, so first point is negative 2, and 1/4 could be here, negative 1.5, and 0, 1, 1, 2, 2, 4, 3, we have 8, it's going to be here. Let's connect the points. Here you go, this is my graph. Now let's fill in. Domain is all of the x values, so it's all real numbers. Range, we can see that it can be all positive y values, so y is greater than 0. As x is approaching positive infinity, f of x, all y values go up, so they also approach positive infinity. As x approaching negative infinity, y values approach 0. So we know that intercept, y-intercept is right there, which is 0, 1, and asymptote is y equals 0. In example 2, we see that our b value is 1/2, but we're going to graph the same way. We will pick x and y values. Let's pick it as negative 2, negative 1, 0, 1, 2. Now, when x is negative 2, basically we need to do like this. Here, when we have a negative exponent, we basically need to switch 1 and 2 places. So I have 2 to the second power, which is 4. So here is 4. When we plug in negative 1, we also need to switch it. So it comes out to be 2. 2 to the 0 power is always 1. When x is 1, we plug it in, we have the same value, it's 1/2. And when x is 2, we have 1/2 to the second power. That comes out to be 1/4. Graph points at negative 2, y is 4, right there. Negative 1, y is 2. 0 we have 1, and 1 we have half. At 2 we have 1/4. As we see, we are approaching y-axis. Okay, so now let's connect the points to draw decay function. As we see, all domain values can be used, so all real numbers. Our range is all of the positive values, so y is greater than 0. And behavior, when x approaching positive infinity, our y value is approaching 0, and as x approaching negative infinity, y values are approaching positive infinity. Now, y-intercept is at 0, 0, 1, and asymptote, we know that graph is approaching y equals 0 line. Now try to compare example 1 and 2 and answer the questions that you have in your notes as we move on to example 3. Let's take a look at transformations of exponential functions. So here we have a, h subtracted, and k that is added. Okay, so take a look. H, which is subtracted from exponents, exponent gives us a horizontal shift. If you add h, it gives shift to the left, and subtract h gives shift to the right. If it's easier, we can use arrows. Right, left, right. Now, k value right here. K is vertical shift. If we add, we go up, and minus, we go down. A value, negative a value gives reflection over x-axis. If absolute a value is greater than 1, it represents vertical stretch of the function. If a value is in between 0 and 1, or a fraction, it gives us vertical compression. Let's take a look at example 3. So when we look at it, I right away can notice that a value is 1/2. My b value is 3. And k value, which is 1. So we know it's lifted up by 1. And a value represents us vertical compression because it's in between 0 and 1. To graph this function, again, we're going to use x and y t-table with values -2, -1, 0, 1, and 2. First value is -2, so when we plug in, it's going to be 1/2, 3 to the negative second power plus 1. I know that this needs to be switched. So I have to multiply two fractions, 1/2 times 1/9, and add 1. So this is going to be 1/18 plus 1. And I can switch it into a decimal using calculator, which is going to come out to be 1.05 is a repeating number. This number is going to go into the table, so 1.05. Next value that we need to plug it in is -1, so 1/2 times 3 to negative first power plus 1. This means 1 over 2 times 1 over 3, and then it's 1 over 6 plus 1. In decimal form, this is 1.16. Repeating. When I plug in 0, that becomes 1, then 1/2 plus 1 is 1.5. When we plug in 1 instead of x, so here I have 3 times 1/2, which is gonna make for me 1/2 plus 1, so that is 2.5. And now next value is 2, so 3 to the second power is 9 times 1/2, it's 4.5. And when we add 1, it becomes 5.5. Now let's graph it. At -2, I have 1.05, should be closer to 1. At -1, 1.16. At 0, I have 1.5. At 1, I have 2.5, so which is right here. At 2, I have 5.5. Maybe another point hard to graph it. Let's connect the points. Now we see that graph is approaching this y equals 1 line, which is my asymptote. Can right in here. Our y-intercept is right here, 0, 1.5. Domain of the graph is all real numbers. Range, I can take anything higher than y equals 1, so y is greater than 1. And as x approaching positive infinity, all of the y values approaching positive infinity as well. And on the other end, as it's approaching negative infinity, y is approaching, or f of x is approaching 1.